questions 8 through 10 on the 2020 Grade 12 Euclid Math Contest. 4 tennis players, Elaine, Bianca, Chen, and Dave, take part in a tournament in which a total of 3 matches are played. First 2 players are chosen randomly to play each other. The other 2 players also play each other. The winners of the 2 matches then play to decide the tournament champion. Elaine, Bianca, and Chen are equally matched. That is, when a match is played between any 2 of them, the probability that each player wins is a half. When Dave plays each of Elaine, Bianca, and Chen, the probability that Dave wins is P. For some real number P, determine the probability that Bianca wins the tournament, expressing your answer in the form AP squared plus BP plus C over D. There are 4 players, A, B, C, and D. And the number of ways that I can get 2 from 4 is 4 choose 2. And that is, of course, 6. So we can just write them out. AB, AC, AD, or BC, BD, and finally CD. If AB is chosen, then the other 2 would be C and D, and they would play each other. If A and C are chosen, the other 2 would be BD. They would play each other, and so on. So the other 2 would be BC here, then AD here, AC, and AB. Now the probability of each of these happening, it's really the full set happening, is 1 over 6 for each of them, because there's 6 possible ways of this occurring. So for example, one way is AB being chosen, and then by default the other match is going to be CD for sure. And then another way of choosing 2 from 4 is getting A and C, and then by default the other 2 teams would play each other. Okay, now we have to start talking about probability. A, B, and C are equally matched. That means when they play each other, each player has a probability of a half of winning. So the probability of A winning here is a half. Probability of B winning here is a half. Very similarly, a half and a half. But when Dave gets involved, he has a probability of winning of P. So P for Dave, but the other guy would be 1 minus P. So A would have a probability of 1 minus P of winning. Similarly, B and C, that's just a half and a half. But whenever D is there, it's P and 1 minus P. So P and 1 minus P like that. And the same story holds true over here. 1 minus P and P. Whenever there's a D, we have to do that. But A, B, and C, when they play each other, it's just a half. So this is 1 minus P and P. This is a half and a half. This is a half and a half. Okay, so that takes care of that initial match. Now we have to start talking about what happens in the final match. So for example, we want Bianca to win the tournament. So she must win here. Wherever she is, she must win that initial match. That's the only way she can advance to the final match. The final match is between the 2 winners. So the final match, I'll write that here. Final match. That's the match that is used to decide who is the tournament champion. It's the winners of the 2 matches. So for this first scenario, the final match could be either B against C, or it could be B against D. And similarly, in this one, the final match could be either B against A or B against C. And in a very similar way, BA, BD, BA here or BD. Let's see here, BA or BC. Those are the final matches. And BC and BD. All right. So, in a very similar way, we have to figure out the probabilities here. The probability of B winning if player B plays C is a half. Probability of B winning here is a half, a half, a half, a half, and a half. So that's pretty straightforward. But here now the probabilities are different. Probability of B winning here is 1 minus P. Here it's still a half. Here it's 1 minus P. 1 minus P. Here it's a half. And here it is 1 minus P. So now we've got to look at 12 different scenarios. These are the 12 different scenarios, but we have to combine it with what happened in the first matches. So here we go. So the first match, 1/6 probability. Probability of B winning is a half. And then the probability that C wins is 1 minus P. And then the probability that B against C wins is a half. So just to recap, the probability of this happening was 1/6, right? Then the probability that B wins is a half. Then we come to this matchup. The probability that C wins that is 1 minus P. And then if C wins that and B has won the first match, then B will play C right here, and the probability that B wins is a half. And that's why we have a 1/6 times 1/2 times 1 minus P times a half. Let's go to the next one. Again, 1/6 probability that this happens, and then the probability that B wins is a half. And then in this match, the probability now that D wins is P, and then if D wins, then B will play D, and the probability that B wins that is 1 minus P. And that's how we're going to proceed. So I'll just do one more and then I'll write them out because you'll get to be an expert. So now the probability of that happening is 1/6. Probability of A winning is a half. And then over here, B has to win this one. So the probability of that happening is 1 minus P. And therefore B will play A, and the probability of B winning is a half. Now we have to take into consideration C winning this time. So again, it's 1/6 that this happens. Probability that C wins is a half. Then the probability that B wins this match is 1 minus P. And then if C is going to play B, the probability of B winning is a half. So there we go. And very similarly, I'll just fill out the rest. And there we go. And we can just take the 1/6 out of all of these because there's a lot of them. Then we can combine them because a lot of these are very similar in terms of their terms. The 1 minus P over 4, that's going to occur, let's see here, once. 1 minus P over 4 occurs several times actually. Here's another one, 2, 3, 4, 5, 6, 7, and 8. 8 times. So I can just put an 8 there like that. That makes it a lot easier for us to calculate. And then the other one looks like a P times a 1 minus P over 2, because remember I factored out the 6. And that occurs 1, 2, 3, 4 times. So there we go. Okay. Not as bad as you thought. So that looks like 8 minus 8p. I'm going to get a common denominator here. And that looks like it's going to be, if I multiply top and bottom by 2, it'll be 8p minus 8p squared. Okay. The 8p's cancel, so all I'm left with is 1/6 times, looks like 4 minus 4p squared. So 4, if I divide through by 4, it'll just be 2. So it'll be 2 minus 2p squared over 6. And then that's just 1 minus p squared over 3. 1 minus p squared over 3 is the answer. But they want it in this format for some reason. Okay, I can get that. So my answer was 1 minus p squared over 3. And they want it in that form. So that would be minus p squared plus 0p plus 1 over 3. Where I guess A is -1, B is 0, C is 1, and D is 3. So for some reason they want it in that form, and there it is. Three microphones, A, B, and C, are placed on a line such that A is 1 kilometers west of B and C is 2 kilometers east of B. A large explosion occurs at point P, not on this line. Each of the three microphones receives the sound. The sound travels at 1/3 kilometers per second. Microphone B receives the sound first. Microphone A receives the sound 1/2 seconds later, and microphone C receives it 1 second after microphone A. Determine the distance from microphone B to the explosion at P. Let's draw a diagram. So here it is. And we have microphone A, B, and C. And some point there's P. And P obviously has to be joined with each of these microphones to illustrate the distance that sound has to travel. All right, we are told that this is 1 and this is 2, and that's about all we're told. But we know that speed is equal to distance over time. So distance is equal to speed times time. All right, so we can figure out these distances without too much difficulty. The first distance I will calculate is PB, P to B. So that will be the speed, which is always 1/3, times the time, which I will just call t. So that's going to be t over 3. The next distance, PA. Again, s times t. The speed is always 1/3, but this time the time is 1/2 seconds more. So it's t plus 1/2. So that's t plus 1/2 divided by 3. All right, now we have this one, PC. P to C, again, S times T, 1/3, but this times T, be careful. This question is tricky. C receives it 1 second after microphone A. Not microphone B, microphone A. So we have to add 1 second to microphone A's time. Microphone A's time was T plus 1/2. We have to add 1 second to that, plus 1, like this. So that basically is what, T plus 3 over 2? Yeah, so T plus 3 over 2 over 3. All right, so we got the distances. They're in terms of T, but we have a pretty decent diagram. And now I'm going to label some angles. This angle I will call theta. And since that's a straight line, this angle is 180 minus theta. All right, we are ready to go. And what are we going to use? Something that is called cosine law. So at this point, I think you guys are experts on cosine law if you're in grade 12 and you're writing a math contest. So off we go. So first I'll do it on this triangle, and then I'll do it on that triangle. So here we go. We've got t plus 1/2 over 3 squared is equal to 1 squared plus t over 3 squared minus 2 times 1 times t over 3 cos theta. All right, pretty good. And that is going to be t squared plus t plus 1/4 over 9. And that is equal to 1 plus t squared over 9 minus 2t over 3 cos theta. 2t over 3 cos theta, let's put it on that side, and then let's get a common denominator and add all this up. This is going to be 9 plus t squared minus t squared minus t minus 1/4 over 9. And this gives me 2t over 3. That doesn't change yet. And this is going to be, oh, the t squareds cancel, so that's very good. So that just leaves me with 9 minus t minus 1/4 over 9. And then that means I can bring the 2t in the denominator. And then 3 and the 9 will just give me a 3. So 9 minus t minus 1/4. Okay, I think that's a pretty decent simplification. Now we will do the exact same thing, but this time on that triangle. So what do we have here? We have t plus 3 over 2 over 3 squared is equal to t over 3 squared plus 2 squared minus 2 times t over 3 times 2 times this time cos of 180 minus theta. And we use a nice identity that some of you, I'm sure, remember, that cos of 180 minus theta is actually equal to negative cos theta. So that definitely helps us. All right, let's expand this. This is t squared plus 3t plus 9 over 4 over 9. This is t squared over 9 plus 4t over 3, and then substituting is cos theta. So what I did was I just put this as negative cos theta, and then that negative would cancel with that negative to give a positive, so that's why it's positive. Okay, let's put everything on one side. I'll keep the 4t over 3 cos theta here, and then put everything else on the other side. I'll get a common denominator of 9, so it'll be t squared plus 3t plus 9 over 4, but then it'll be minus t squared, and then the 4 will be minus, but then it'll be 36 because I had to multiply top and bottom by 9. So now let's see here, the t squared is canceled, so that's good. That leaves me with 3t plus 9 over 4 minus 36 over 9 is equal to 4t over 3 cos theta. And then that 3 will cancel with the 9 to give a 3, and then put the 4t in the denominator. And the top I can just leave like this. I won't bother to add the fraction. All right, great. So I got two values for cos theta. What's the next step? Of course, logically set them equal to each other. So 9 minus t minus a quarter is equal to 6t. Here it's 3t plus 9 over 4 minus 36 over 12t. So the 6t and the 12t just leave a 2. So it's basically going to be 9 minus t minus a quarter, 3t plus 9 over 4 minus 36, and then just a 2. Cross multiply, and you'll get 18 minus 2t minus a half, 3t plus 9 over 4 minus 36. I think I can combine like terms here. 5t, and put all the numbers on the other side. 18 minus a half plus 36 minus 9 over 4. When you crunch out these numbers, you get 51.25, and then therefore t is equal to 10.25. All right, what did we want in this question? Determine the distance from microphone B to the explosion P. So that would be t over 3. That's the distance. So we have to calculate the value of t over 3. Okay, well I got t. So t over 3 will be 10.25 over 3. Multiply top and bottom by 4, and you get 41 over 12. So there you go. An L shape is made by adjoining three congruent squares. The L is subdivided into four smaller L shapes as shown. Each of the resulting L's is subdivided in the same way. After the third round of subdivisions, how many L's of the smallest size are there? Well, we have basically been shown what happens after the round one. So each L is subdivided, as you can see, into 4. So here we had just one L, here we have 4. So after round 2, each of these will also be subdivided into 4. So this guy, for example, will be subdivided into 4. This one will be subdivided into 4. This one will be subdivided into 4. And this one will be subdivided into 4. So after round 2, we'll have 16 of those L shapes. Okay, I think you get the hang of this. After round 3, what happens? Well, after round 3, basically the same thing. Each of those will generate 4. So if we have 16, then we will now generate 16 times 4, which is 64. So that's really all they're getting at with part A. 64 is the answer there. Part B. After the third round of subdivisions, how many L's of the smallest size are in the same orientation as the original L? The original L is in this orientation. So after round 1, I hope you can see that that one and that one are in the same orientation. The other ones are not. Okay, so we have to have some sort of a system here. Instead of counting, that would be out of sort of any structure. We want to have a structural system of figuring this out. So here we go. I will first draw what are the different possible shapes. And I believe there's only 4 shapes. There's this one. There would be this one. And then I guess you flip them. So here's one, and then here's another one. These would be the 4 shapes. And I'll give them just names. I'll call this A. I'll call this one B. And then C and D. Why not? Okay, so here we go. In the very beginning, we have this one. And of course, we have to go to our first sort of subdivision. And they drew that out for me. They did a little bit of work to help us out. And when they do that, we can see how many, after round 1, are in shape A, B, C, or D. Okay, well, let's see. How many are in shape A? Well, this is A, this is A, so 2. How many are in shape B? Just this one, that's B, just 1. And how many are in shape C? Just this one, that's C, so 1. And there's no D, interestingly, 0. Now, what about same orientation? Same orientation as the original one? Well, the original one is actually A in terms of its orientation, so there's 2. There's 2 of them. So there we go. That is just after round 1, though. They want you to do 3 rounds of subdivisions. Okay, not a problem, I think. Now, after this, we get to, I'm not going to draw out the shape because obviously there's going to be way too many divisions. We don't need to draw it out. We can just work it with a table. So they will have A, we will have B, we will have C. And interestingly, we don't have to worry about D because D is 0. Okay, for A always splits into the following. It always makes 2, 1, 1, 0, right? Because here we went from A to that. A made 2, 1, 1, 0. A always results in 2, 1, 1, 0. So that one we've got. What about B? Okay, I'm not sure. So what I'll do is I'll just draw a B. And I'll see what happens when I split it. So here's a B. And let's just split it the way we're supposed to. And then let's see what happens. This is a B being split into 4 different L's. Okay, well, it looks like I got a B here. I got a B here. And this is a D. And this is an A. Okay, so B splits, if I were to make a little tally here, it looks like 2, 0, 1, and 1. Yeah, 1, 2, 0, 1. Okay, great. And then C. All right, so I've got to do the same thing. I've got to split a C and then see what I get. So here's a C. And let's see what happens when I split the C. Okay, so this is the split. Looks like I got C and C, and then this is a D, and this is an A. Okay, so C gives me A, B, C, D. 2 here, 1 here, 0 for B, and 1 for A. 1, 0, 2, 1. All right, great. Now that was after, this is after round 2. So after R2. All right, so now what we have to do is go to round 3. But you say, well, this is really time consuming. Do I really have to do it for this and this and this and this? And man, but the answer is no. You can just add them up. You can get a total. So let's do the total. The total A's, 2, 1, 1. That's 3. You see how we're making our life a lot easier? But be careful, because I had 2 A's. So each of those A's gives me 2. See what I mean? So there's 2, but each of those A's gives me 2. So that's actually 4. And then 5, and then 6. So the total A is 6. Total B. Again, we have 2 of these A's. So everything here has to be counted twice. So 1, 2. And then 3, 4, and that's it. There's 4 B's. And then for C and D, for C, it looks like we have to count this twice, and then we have to do this 2. So we have 4 there. And for D, 0, 1, and 1. So D is 2. So now that's a lot better, right? I mean, it's much easier to work with this than to work with all of this individually. Okay, now let's do the same thing for A, for B, for C, and for D. What happens? For A, well, we do the same thing. A always goes to 2, 1, 1, 0. So I can write it here, A, B, C, D, 2, 1, 1, 0. B, what does B produce? Well, we did B here, right? B produces 1, 2, 0, 1. So A, B, C, D, 1, 2, 0, 1. C. C we did right here. That produces, let's see here, 1, 0, 2, 1. 1, 0, 2, 1. And then D. D we haven't done yet, interestingly. Okay, let's do that. D's right here. Might as well just do it right there. So D, let's see, it looks like it will produce a D here, a D here. And this looks like a B to me, and that looks like a C. So D will produce 0, 1, 1, and 2. Okay, so let's figure out the total this time. And we got to be careful. So we can easily tally this up. This 6 has to be multiplied with all of those, so that's going to give me 12, 6, 6, and 0. This 4 has to multiply all of those guys, so the totals will be 4, 8, 0, and 4. This 4 has to multiply all those, so that's going to give me 4, 0, 8, and 4. And this 2 has to multiply these guys, so that's going to be 0, 2, 2, and 4. Now the total you can easily get by just summing up all these. So the A's, 12, 4, 4, and 0, so that is 20. The B's, 6, 8, and 2, and that is 16. The C's, 6, 8, and 2, again that's 16. And the D's looks like 4, 4, and 4, which is 12. All right, now we can answer the question. After the third round, so this was after round 3. After 3 rounds, how many L's of the smallest size are in the same orientation as L? Well, the original orientation of L was A, so how many are in the same as A? Well, according to our table, the answer is 20. So that completes part B. Part C, starting with the original L shape, 2,020 rounds of subdivisions are made. Determine the number of L's of the smallest size. They're in the same orientation as the original L. Well, we are obviously not going to do 2,020 rounds. So what I want to do is just one more round and see if I can get some sort of a pattern. If I can extrapolate that pattern to 2020. So let's do that. So this was my scenario after round 1. This was my total after round 2. And this was my total after round 3. So let's do one more round, and we'll call it, obviously, after round 4. So here we go. So this is our total. This is my starting point. So same story. We have A. A would produce, you're an expert now, it would produce 2110. B produces, you can look back and see what we did previously. B produces this guy, which is 1201. And then C, that produces this right here, which is 0. A, B, C, D would be 1021. And then D, that one we did somewhere. Let's see here. We did that here. And in particular, just this. That produces 0112. 0112. Okay, so now let's do the totals. Remember, I've got to multiply. So 20 times 2, the totals would be 40, 20, 20, and 0. Now, 16 is what I have to multiply by these. So it's going to be 16, 32, 0, and 16. Also 16 is what I multiply those guys. So that's going to be 16, 0, 32, and 16. And this is 12. And that's what I have to multiply here. That's going to be 0, 12, 12, and 24. Okay, now let's get the totals. So the total after round 4, total, A, B, C, D. Let's add this up. So we got 40, 16, 16. That is 72. And then for B, 20, 32, and 12. So that is 52, 12, 64. Yeah, 64. Okay. C, 20, 32, 52, and 12, 64 again. Okay. And then D, 16, 16, and 24. So that's 56. All right, great. So I got my total after round 4. Now I have to look at this and figure out a pattern, because I don't really want to keep going, right? Because that's going to be pointless, and obviously there's no way you're going to go 2,020 rounds. And really all I want to look at is the totals. So that's why I've got this after round 1, this is after round 2, this is after round 3, and I just calculated this after round 4. Okay, so let's figure out the general rule. After round n, let's say, where n is some number, what will be my total for A, B, C, and D? So I have to stare at this and see some sort of a pattern. Now I'm going to start by looking at just B and C, because B and C seem to be the same every time. And after I stared at this for a while, it looked to me that B looks like powers of 4. It's 1 here, it's 4 here, it's 16 here, it's 64 here. So I'm pretty confident that B is going to be 4 to the power of n minus 1. Not n, but n minus 1. So, for example, when n is 4, it would be 4 to the power of 3, which is indeed 64, and so on. Okay, so I'm pretty confident about that. But I've got to figure out A. They don't want me to figure out B and C. They want A, because A is what is in the same orientation as I did in part B, if you remember. Okay, so then I've got to look at the number 2, 6, 20, and 72. And from those numbers, I've got to figure out a pattern. So I thought about this. I said, oh, okay, powers of 2, powers of 3, powers of 4. Well, neither of those. But after I looked at it and stared at it and analyzed it, I came up with something that works. And that is, it looks to me that 2 looks like 4 to the power of 0 with 2 to the power of 0. Right? Because 2 is obviously 1 plus 1. And then that 6 looks like it's 4 to the power of 1, which is 1. This is 4, plus 2 to the power of 1, which is 2. The 20 down there looks like 4 to the power of 2, which would be 16, plus 2 to the power of 2, which is 4. And that 72 looks like 4 to the power of 3, which is 64, plus 2 to the power of 3, which is 8. And that's definitely the pattern. So, in general, it would be 4 to the power of n minus 1 plus 2 to the power of n minus 1. And therefore, 2020, when n is 2020, so when n equals 2020, the value for a would basically be 4 to the power of 2019 plus 2 to the power of 2019. And that's the answer. So it's a great question. It's very, very interesting, and I think the mathematics is very reasonable. And I like how they progressed. They first gave you A and then B and then C, because I think if they had immediately just jumped to C, it might have been a little too difficult. But when they progress from A and then to B and then to C, it allows you to develop the question and the solution, and allows you to come up with a successful answer. Cayley has a list of n integers a1 to an, satisfying a1 less than a2, and so on. Cayley calculates the pairwise sums of all m equals 1/2 n times n minus 1 possible pairs of integers in her list and orders them pairwise sums as s1 less than s2 and so on until sm. For example, if Cayley's list consists of 3 integers 1, 2, 3, the 3 pairwise sums are 3, 5, 6. So this, don't get confused by that. They're just saying how many pairwise pairs are there? How many pairs are there? For example, if there was 5 numbers, then that is equal to n. So I say if there's 5 numbers, how many pairs are there? Well, for the first number, you have 5 choices. For the second number, you have 4 choices. And then you have to divide by 2 because pairs can be the same. Like a1, a2 is the same as a2, a1 in this case. So you've double counted, and that's why you divide by 2, so it'd be 10. And that's all that this is. It's just n times n minus 1 divided by 2. That's m. All right, so let's turn our attention to number 10a. Suppose that n is equal to 4, and therefore the 6 pairwise sums are 8, 104, 106, 110, 112, and 208. Determine 2 possible lists of a1 to a4 that could Cayley have. All right, so n is 4, so that means the number of pairwise sums, m, would be 4 times 3 divided by 2, which is 6. And they've already told you that, 6 pairwise sums. Okay, so a1, a2, a3, and a4, those are my terms. Now let's figure out those pairwise sums. There's not that many. There's only 6, so I can just easily write them out. a1 plus a2, a1 plus a3, a1 plus a4, then a2 plus a3, then a2 plus a4, then a3 plus a4, and I believe that's all of them. Now, I have to assign them to S1, S2, S3, and so on. Okay, well, I'm confident that S1 is the smallest and S6 would be the biggest. And then for the first one, I'll just do them in order. Like that, S1 through S6. All right, and then each of these, they've actually given me numerical values. They've given me that this is 8, this is 104, 106, 110, 112, and 208. All right, so I've got 6 equations, 4 variables. I think I can easily solve this. So let's see here. From this one I get, or actually let's go with this one. I think that would help better. A1 is equal to 104 minus A3. And then from this one, I get that A2 is equal to 110 minus A3. So now I can sub them back into here and solve. So that's going to be 104 minus A3 plus 110 minus A3 is equal to 8. So that gives me 214 minus 8, which is 206, is equal to 2A3. So A3 is equal to 103. All right, great. So if A3 is equal to 103, I can easily calculate A1. That's going to be 104 minus 103, so that's just 1. A2 is 110 minus 103, which is just 7. And then A4 plus A1 is equal to 106. So that means A4 looks like it's going to be 105. And that's it, right? Yeah, so my list I got was A1 was 1, A2 was 7, A3 is 103, and A4 is 105. Okay, great. But they're saying there's 2. Okay, so how do I get a second list? I think I did everything right here. Well, a second list. Interesting. I think that A1 plus A2 is definitely going to be 8. That's got to be the smallest. And then A3 and A4, that has to be the largest. I'm pretty confident about that. And I'm also pretty confident about the A1 and A3 being 104. And also the second last one, A2 plus A4, being 112. A2 plus A4. But I think that these ones can be interchanged. So I think that A1 plus A4, here I had put 106, but I think it can be 110. That is possible. And then therefore A2 plus A3, here I had put 110, but I think it can be 106. So this will allow me, hopefully, to get another set. So the math is the same sort of story, I guess. A1 is going to be 104 minus A3. And then this one here, A2 will be this time 106 minus A3. So same thing as before. We can sub them into there. So that means 104 minus A3 plus 106 minus A3 is equal to 8. So that's 210 minus 8, so 202 is equal to 2A3. So A3 is 101. There we go. We did indeed get a different value for A3 because back then we got 103. And then A4 I can easily get. A4 plus A3, we can just use that one. That's 208. So that means A4 will be 208 minus 101, which is 107. So I did indeed get a different list. A1 this time, well, I didn't even calculate it yet. A1 is going to be 104 minus 101, so 3. And then A2 will be 106 minus 101, which is 5. So that list is 3, 5, 101, and 107. So indeed, there are 2 possible lists. And this is the first one, and this is the second one. Suppose that n is equal to 5 and that the 10 pairwise sums are S1, S2 until S10. Prove there is only one possibility for Carey's list, A1, A2, A3, A4, A5. So this time we have 5 for n, and we have, of course, therefore, these 5 terms. And we have to now prove, unlike the previous part where there was 2 sets, here we have to prove that there's only one set. Okay, so what are, first of all, our pairwise sums? A1 plus A2, A2 plus A3, and so on. Now, if we add all these up, we will get 4A1 plus 4A2 plus 4A3 and plus 4A4 and 4A5. And that is the total sum, so I'll just call that S for now. Don't really know much about what that sum is. So now let's see how I can assign these S's. I'm pretty confident that the smallest one is S1 and the largest one is S10. And just as before, I'm also confident that the second one will be S2 and the second last one will be S9. But the middle ones, those ones can vary. So I'm not sure. So the only ones that are fixed are these ones. So I'll just put fixed beside them to show that they're fixed. Fixed meaning those are set. Those will never change. And also, the total sum is fixed. No matter what the order is, the total sum will also be the same, no matter what the order is. Okay, so looking at that total sum, it looks like it's 4 plus, if you factor out the 4, it's just A1 plus A2 plus A3 plus A4 plus A5. And therefore, it looks to me that if we just take this and divide by 4, it's going to be A1 plus A2 and so on, right? But some of these we already know based on what I wrote over there on the right side are actually fixed. Which ones are those? A1 plus A2, that's fixed as S1. And then A4 plus A5, that's fixed as S10. And A3 is in the middle there. So that means I can isolate for A3. A3, it looks like it will be S over 4 minus S1 minus S10. And since S is fixed, S1 is fixed, and S10 is fixed, S3 is fixed, meaning it has only one value. All right, so that is basically how we proceed with this question. And then you do the same sort of thing as you did before. You can use these equations to solve for the other ones. So A1 is, for example, S1 minus A3, or sorry, S2 minus A3. So A1 would be equal to S2 minus this whole thing. So minus S over 4 plus S1 plus S10, like that. And in a very similar way, you can solve for A2. A2 would be equal to S1 minus A1 from that equation. So that's going to be A2 is equal to S1 minus A1. So this whole thing minus S2 plus S over 4 minus S1 minus S10. And that simplifies to just A2 being minus S2 plus S over 4 minus S10. And since S2 is fixed and S is fixed and S1 is fixed and S10 is fixed, that means the value of A1 is fixed. And in a very similar way, A2, since S2 is fixed and S is fixed and S10 is fixed, the value of A2 is also fixed. So what did I get? I got A1, A2, A3, A4, and A5. I'll let you do that. I'll just write out the values. A4, you can easily get right. You can get the A4 by writing out, or actually probably figure out A5 first. That'll be a little easier. That will be S9 minus A3. And when you do that math, you will get A5 is equal to S9 minus S over 4 minus S1 plus S10. And finally, you'll be able to get something similar for A4. That's going to be S10 minus A5. And when you crunch out that, you will get minus s over 9 plus s over 4 minus s1, because the s10s will cancel. And here we go. So A5, S9 is fixed, S is fixed, S1 and S10 are fixed. So that is also a fixed value. And finally, A4, well, S9, S, and S1 are all fixed. So that's also fixed. So that means our values for A1, which is this, is fixed. A2, which is this, is fixed. A3, which is this, is fixed. A4, which is this, and that's also fixed. And A5, which is this, is fixed. Meaning all 5, A1, A2, A3, A4, A5 are all fixed. Therefore, there's only one list. There isn't any discrepancy as to what it could be in another order. They're always going to be the same. So we have proven part B, which is that there's only one possible list A1 through A5. Suppose that n is equal to 16. Prove that there are two different lists, A1 through A16 and B1 through B16, that produce the same list of sums, S1 through S120. Well, this time n is 16, so the number of pairwise lists as before, n times n minus 1 divided by 2. So that we get 16 times 15 divided by 2, which is 8 times 15, which is 120. So that's why we're going up to S120. All right, so in part A of number 10, we showed that when n was 4, you get two lists. If you remember, we had two different A1, A2, A3, A4. And if you recall, those lists were 1, 7, 103, 105, and the other one was 3, 5, 101, and 107. So we showed that when n was 4, you can get two lists. So they want you to do the same sort of thing, that there's two different lists, but this time for n equals 16. Okay? So how do we do that? Well, one thing I want to point out is that these two lists, if you recall, they produce the same sums, S2, S3, S4, S5, and S6. And I had shown that because n is 4, the number of pairwise sums would be 4 times 3 divided by 2, which is 6. And that's why we're going up to S6. And when you use this list and you make the pairwise sums, they would produce S1 through S6. And then when you use this list and make the pairwise sums, they would produce the exact same list, same numbers. So those two lists produce the same pairwise sums. All right, so now we have to approach the n equals 16. But first, I'm going to start with n equals 8. Let's work our way up here. Now, m would be equal to 8 times 7 over 2, which is 56. So now we have 56 pairwise sums, so quite a few. So, or sorry, that's actually 28. 8 times 7 divided by 2 is 28. So if n equals 8, I've got A1, A2, A3, and so on up until A8. And then the sums, the pairwise sums, S1, S2, dot, 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 all the way up until S28. So there's quite a few this time. All right, so what will our terms be? Well, the first way of approaching this is just using the ones I have up here. But instead of using those numbers, I'll just illustrate them as letters. So A1, A2, A3, A4. And then for the second list, I will use B's, B2, B3, B4. Now here is indeed a list of 8 terms. But what I'm going to do, and this is the heart of the question, is we have to add a certain integer to 4 of these sums. So I'm going to add x. So plus x. Like that. And therefore, we will have pairwise sums with these 8. So the pairwise sums will be of 3 forms. The first is anytime you pair something like an A1 with another A. So for example, that's just an example. That type of a pairwise sum, an A with another A. So that produces the same sort of story as here. It will produce these 6 sums. If you just take these guys and make pairwise sums, it produces those 6 sums. Produces 6 sums. Right? Just as before. S1 to S6. Dot, dot, dot. The next type of pairwise sum would be if we combine something from here with something from here. So, for example, B1 plus X plus B2 plus X. Something like that. That's just an example. And that becomes B1 plus B2 plus 2X, right? So that is just basically B1 plus B2 with some additional 2x. X is an integer. So basically, the B1 plus B2 situation also produces 6 sums. And those 6 sums will be the same. S1 dot 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 S to S6. Because we can pretend that these were A1, A2, A3 like that. And these are B1, B2, B3. So let me write that in. So that's basically allows us to conclude that if you were to take 2 B's and add them, it would eventually produce the same pairwise sums, S1 through S6. Now the next and final type of pairwise sum, if we added one of these guys with one of those guys, that's a little different. So for example, A1 plus B1 plus X. Those type of pairwise sums are a little bit different. That has to be looked at in a different way. For the A, there's 4 possible choices, right? Either A1, A2, A3, or A4. So there's 4 possible choices. For B, there's 4 possible choices, either B1, B2, B3, or B4. So the number of different pairwise sums you'd have to multiply, and that's going to be 16. So this scenario produces 16 pairwise sums. All right, so how many did we get in total? We got 6, 6, and 16, and that is 28. And that's how many we needed. So that works out. Now what you have to do is you have to do pretty much the same thing, but this time we add the x to the a's. So this time it's A1 plus x, A2 plus x, and so on. A3 plus x, A4 plus x. And then the b's we add just by themselves, B2, B3, B4. And we do the same story. The pairwise sum this time could be, say, they could be like B1 and B2. That's one way. And they would produce 6 sums. Exactly like we had up here. Same story. Then we can also have a scenario where we add 2 of these guys. Say this and this. So for example, A1 plus x plus A2 plus x. That is very similar to A1 plus A2 with an additional 2x, and that's also going to produce 6 sums. Very similar to this right here. And then the third scenario is when we add one of these to one of these guys, and that is, for example, A1 plus x plus B1. And that, there's 4 choices here, 4 choices there. 4 times 4 is going to give me 16 sums. So as before, 6, 6, and 16, that's 28. And those sums will be the same because these sums are just S1 until S6. This is also S1 until S6. And these will be the exact same as 3 above. So this is what I mean by 3 above. Because essentially it's the same, right? A1 plus B1 plus X. A1 plus X plus B1. Doesn't matter if you rearrange it, the sum will be the same. So that shows that if you have 8 terms of this form, and then 8 terms of that form, and you use those 2 different sets of 8 terms, you'll get the same pairwise sums. Now we have to show this, and I'd like to show it with a number. So far I've just put an X, right? But I'd like to show that it actually does work with an actual number. But how do I choose X? That's the crucial thing. Well, you choose an X as follows. Choose an X such that, or so that, any of those A's, when you add it to X, cannot equal any of the B's, right? Because otherwise it wouldn't be different. If we added an X to an A and it's the same as a B, it wouldn't be a different list. It would be the same list. And the same thing that any of those AI plus X that cannot equal a BJ plus an X. Or actually, a better way to write that is that BJ plus X is not equal to any AI, because if it was, it would be the same list. Okay, so I have pretty much an infinite choice for X, it seems like. So I guess I just choose something. So let's first write out my A's. And if you recall, the list was 1, 7, 103, 105. And the second list was 3, 5, 101, 107. Okay, so I've got to choose an X. So whatever, it doesn't matter. I'll just choose 200 because that way it won't make a difference. None of these will be the same because X is way beyond any of these. So first let's add it to my list number 1. This is going to be the same, but that X will be added to each of those B's. So this will be 203, 205, 301, and 307. And then list number 2, I'm adding X to the A's. So this is going to be 201, 207, 303, and 305. And the B's are 3, 5, 101, and 107. Okay, with these 2 lists, I've got to show that my pairwise sums are the same. Okay, so I've got a lot. S1 through S28, right? Okay, so I think I can do that pretty quickly. Right, A1 plus A2, A1 plus A3, and so on. So A1 plus A2 is 8. A1 plus A3 is 104. A1 plus A4 is 106. A1 plus B1 in this case is 204. And you get the hang of this. So 206, 302, 308. And then very similarly, I'll just create all the pairwise lists for this first set. And there you go. These are the 28 S1 ... until S28 pairwise sums of this list right here. And that list is basically when I took A1 and A4 and wrote it the way it is, but I took B1 through B4 and added X equals 200. And like I said, there's infinite values that you can use for X. There's no one specific value that is, accurate or ideal or whatever. Okay, so now you have to do the exact same thing for the second list because we have to show that it has the same sums, pairwise sums. So I'll do that. I'll just walk you through the first couple. The first one would be, 201 plus 207, which is 408. And then 201 plus 303, which is 504. And then 201 plus 305, which is 506. And then 201 plus 3, which is 204, and so on, right? So I'll make that list. And there we go. And when you compare this list to this list, you will see that they are exactly the same. Now, the order is a little different, and that's fine. But when you arrange them from smallest to largest, S1 less than S2 less than ... all the way until S28, you'll notice that that order will be exactly the same. So there we go. We've just proved it. But we proved it for n equals 8. The question was asking us to prove for n equals 16. And I think this is sufficient if you wrote the following. Using a similar analysis to that above, if the lists A1 through A8 and B1 through B8 have the same set of pairwise sums, then the lists A1 through A8 with B1 through B8, where you add y to each term for the b's, and this is 16 terms, and A1 plus y, A2 plus y, all the way to A8 plus y with B1 through B8, another 16 terms, will also have the same pairwise sums. And therefore, setting y equals 1,000,000, I don't know why they chose 1,000,000. You can choose any number, really. It's not like 1,000,000 is the only correct one. So some arbitrary number with the certain conditions that I had described above. We see that these lists, and they're just making two lists, have the same list of sums S1 through S20 as required. So it's the same thing. It's just repeating itself with a n that's double to before. Before it was 8, now it's 16. And I think that should be sufficient for this very challenging question.